मेकॅनिझम ऑफ रेस्पिरेशन हे युनिट चालू केलेले आहे. त्याच्यामधले 4 पॉईंट्स टोटल A, B, C आणि D. A ब्रीदिंग, B एक्सटर्नल रेस्पिरेशन, C इंटरनल रेस्पिरेशन आणि D सेल्युलर रेस्पिरेशन. आता हा शेवटचा पॉइंट मेकॅनिझम ऑफ रेस्पिरेशन मधला आपल्याला पूर्ण करायचा आहे आणि तो म्हणजे सेल्युलर रेस्पिरेशन. राईट. So it is the last step in the mechanism of respiration. Actually it occurs inside the cell where food is oxidized and ATP is released. Up till now we have studied this mechanism of respiration at lung level, at tissue level and so on. This cellular respiration occurs inside the cell where food is oxidized. Now you are well known, the food is transported through digestive system through circulation and reaches up to each and every cell of our body. This cellular respiration involves two states. One is oxidation, another is phosphorylation. What is meant by oxidation? The food, you know very well, for example, glucose. When food is digested and assimilated and absorbed along the intestinal lining and enters into blood and reach up to tissue or cell, it is in a very simple form glucose, C6H12O6. Now respiratory mechanism provides oxygen up to tissue level. In presence of this oxygen, the glucose is oxidized and energy is released. The byproducts are formed are carbon dioxide and water, and about 686 kilocalorie energy is released. Now here what happens actually, the complex organic molecule, which is the complex organic molecule glucose. This complex organic molecule is broken down into a very simple inorganic molecules like water, carbon dioxide, and energy is released. So during oxidation, complex organic molecule is converted into simple or inorganic molecule to release energy. That is called as oxidation. The second step is phosphorylation in cellular respiration or at tissue level or cell level. It involves trapping of heat energy in the form of high energy bonds of ATP. And now you know ATP is used to carry out different life processes like digestion, excretion, nervous coordination, hormonal coordination, reproduction and so on, circulation. Hence it is called currency of cell. Remember, this word will be asked in MCQ. What is the currency of cell or define currency of cell? So ATP is used to carry out life processes, hence called currency of cell. How it can be summarized? The adenosine diphosphate added with one phosphate bond here requires 7.3 kilocalories energy and forms ATP. Or when ATP is broken down into ADP, breaking one phosphate bond, release about 7.3 kilocalorie energy. And this energy is utilized by each and every cell to perform their own functions. For example, epithelial tissue functions, protection, secretion, etc. Connective tissue connection, gives support, binds. Muscular tissue For example, contraction and relaxation, and by the way bring about movement and locomotion. Neurons brings about nerve impulse conduction. So all these life processes, life functions carried out by this energy. Hence that energy is known as currency of cell. So here we complete the unit 8.3 known as mechanism of respiration, under which we have studied 4 different points: breathing, external respiration, internal respiration, and cellular respiration. Now under this unit in our textbook, in one bracket, some pulmonary volumes and capacities, the normal values, are given. Now these are very much important in point of view of examination, because all these are 1 mark questions. Maybe asked in MCQ, maybe asked for answering 1 sentence. So these pulmonary volumes or capacities normally studied under 2 headings: 1 lung volume, A lung volume, and B lung capacities. The lung volumes are of different kinds. For example, tidal volume or TV, inspiratory reserve volume or IRV, expiratory reserve volume or ERV, dead space or DS, residual volume or RV. Now we'll study 1 by 1. What is tidal volume or TV? Remember short forms also. Short forms are also asked in MCQ. It is the volume of air inspired and expired during normal breathing. When you are at rest, sitting in a chair or sitting in your bench, and your breathing is going on, during which the inspiration and expiration cycles occur, and during which about 500 ml maximum, 500 ml air is inspired and expired. That is called as TV or tidal volume. Second concept or value is about IRV, means inspiratory reserve volume. IRV. What is IRV? It is the maximum volume of air or extra air inhaled during forced breathing in addition to TB. So remember, it is maximum air inhaled during forced breathing in addition to TB. So it is a maximum value inhaled during forced breathing in addition to TB. That means if you minus TB 500, so exactly IRV is 1500. Right? So total volume is about, normal volume is about 2000 to 3000 ml. Next is expiratory reserve volume or ERV. This ERV means maximum volume of air exhaled in IRV inhaled, in ERV exhaled during forced breathing, after normal expiration, and it is about 1000 to 1100 milliliter ml. So that is about IRV and ERV. IRV and ERV are exactly opposite. IRV is maximum volume of air inhaled during forced breathing, and this is maximum volume of air exhaled during forced breathing. It is 2000 to 3000 ml. It is 1000 to 1100 ml. Now next is dead space or DS. What is DS? DS means volume of air that is present in respiratory tract. Now you are well known about respiratory tract. Respiratory tract starts from nose and ends up to alveolus. So, from spatially nose to terminal bronchiole, that means up to alveolus. From nose to terminal alveolus, but not involved in gaseous exchange. Not involved in gaseous exchange. That means actually not that volume of air in alveolus. Only up to terminal bronchiole. That volume of air is about 150 ml. Its value is about 150 ml. So that is called dead space. Clear? Then residual volume or RV. Now RV means volume of air that remains in lungs and dead space. The volume of air that remains in lungs and dead space after maximum expiration. After maximum expiration, and its normal value is about 1100 to 1200 ml, right? Or 1100 to 1200 ml in simple word. So these are the lung volumes: TV, IRV, ERV, DS, RV. TV is about 500 ml, IRV is about 2000 to 300 ml, ERV is about 1000 to 1100 ml, DS is about 150 ml, and RV is about 1100 to 1200 ml. Now we go to the lung capacities. The total lung capacity, it is also called as TLC. The maximum amount of air that can be held by lung after maximum forceful inspiration. When you take a breath and can hold maximum amount of air inside your lungs, and normally a person can hold about 5200 to 5800 ml volume of air inside the lung, and that is called as total lung capacity. Second is vital capacity, VC. What is VC? The maximum amount of air that can be breathed out. Remember, breathed out, maximum amount. And after maximum inspiration. So remember, when you take forceful inspiration and then you forcefully expire the air, breathe out the air, during which how much volume of air is present inside that lungs, it can be calculated by adding TV plus IRV plus ERV. And you are well known, TV is about, that means starter volume is normally about 500 ml. Then IRV is about 2000 to 3000 ml. And ERV is about 1000 to 1100 ml. So roughly all these figures, if you summarize or make it, you can say addition, it is about 4100 to 4600 ml. It comes about 4100 to 4600 ml. So in short, the capacities of lungs can be studied by two ways. One is total lung capacity, another is vital capacity. Total lung capacity after maximum forceful inspiration is about 5200 to 5800 ml. 5200 to 5800 ml, and VC is about 4100 to 4600 ml. So remember all these figures, remember all these short forms of each and every volumes and capacities, and also remember their meaning. So that will be asked for 1 mark. So here now we complete 8.3 subunit of our respiration topic, under where we have studied the mechanism of respiration and pulmonary volumes and capacities. Okay, so I will send the notes along with this photograph of blackboard. Write it down in your notebook and solve the exercise present in our text.